What if the moon disappeared tonight? Think about the moon for a second. You see it almost every night. You've looked at it thousands of times, and you have absolutely no idea how much it's actually doing for you. Seriously, stop and think. What would happen if it just vanished? Not exploded, not broke apart, just gone. 1 second it's there. The next second, empty sky. Would we even notice? Sure, we'd notice the night sky looks weird. We'd notice the tides feel wrong. But that's just the beginning, isn't it? The moon isn't just a pretty light in the sky. It's a cosmic anchor. It's the thing that keeps our planet from wobbling itself into oblivion. Here's the first thing you need to understand. The moon is massive. Not massive compared to Earth, but massive enough. 1/4 the size of our planet. That's huge for a moon. Most moons are tiny compared to their planets. Ours is a giant, and that giant is holding us steady. Dr. Sarah Stewart, a planetary scientist at UC Davis, puts it this way. The moon is Earth's stabilizer. Without it, our axial tilt would wander wildly over millions of years. Wandering wildly. That's a polite way of saying our climate would go completely insane. But let's start at the beginning. The very beginning. How did we get this thing in the first place? About 4.5 billion years ago, Earth wasn't Earth as you know it. It was a baby planet. Still forming, still hot, still chaotic. And it had a rival. A Mars-sized body called Theia. They collided, not a gentle bump. A full-on cosmic car crash. The impact was so violent that it vaporized Theia, and a huge chunk of early Earth went with it. All that debris, it didn't fly off into space. It stayed, it orbited, it clumped, and over millions of years it formed the moon. That's right. You're looking at a piece of Earth every time you look up. The moon is us. Now here's the terrifying part. That huge hunk of us, it's moving away. Every year, about 3.8 centimeters. The moon is slowly escaping Earth's gravity. It's been doing this for billions of years. When it first formed, it was about 15 times closer. Imagine that. A moon 15 times bigger in the sky. Tides 15 times stronger. Days 15 times shorter. Because here's something you probably don't know. The moon controls your days. Not the length of your day right now, but the length of your day over time. The moon's gravity pulls on Earth's oceans. That creates tides. And those tides, they slow down Earth's rotation every single day by a tiny fraction. But over billions of years, those tiny fractions add up. When the moon first formed, a day on Earth was maybe 6 hours long. Can you imagine that? Sun rising and setting in the time it takes you to watch a movie. The moon has been slowly stealing Earth's rotational energy and using it to push itself further and further away. So let's do the thought experiment. Let's say it happens tonight. The moon disappears. Poof. First thing you notice? The night sky looks wrong. Empty. But that's the least of your problems. Next thing? The tides. But not in the way you think. The tides don't just vanish. They change. Completely. The moon drives about 70% of Earth's tides. The sun drives the other 30%. So you'd still have tides, but they'd be weaker. About 1/3 of what they are now. But here's the thing. Tides aren't just about waves at the beach. They're about ocean currents. They're about nutrient mixing. They're about the entire food chain of the ocean. Fish migrations, plankton blooms, coral reproduction, all of it tied to the rhythm of the tides. That rhythm would break. And the ocean ecosystem, it would break with it. But that's nothing. That's surface stuff. The real problem? The spin. Remember how I said the moon stabilizes Earth's tilt? Earth's axis is tilted at about 23.5 degrees. That tilt is what gives us seasons. Summer, winter, spring, fall. All of it. And that tilt is currently stable. Because of the moon. Without the moon, that tilt starts wandering. Dr. Jacques Lascar, an astronomer at the Paris Observatory, ran the numbers. Without the moon, Earth's axial tilt could change by as much as 85 degrees over millions of years. That's not seasons. That's chaos. That's the climate going from ice age to tropical in a single century. That's ice caps melting and reforming in the blink of a geological eye. But wait, it gets worse. That wander, it wouldn't happen slowly. It would happen in cycles, over 100,000 years, over 500,000 years. The tilt could swing wildly. 0 degrees, no seasons at all. 45 degrees, extreme seasons. 85 degrees. The poles point at the sun. Think about what that means. No stable climate, no stable agriculture, no stable human civilization. Everything we've built in the last 10,000 years, it was built during a period of climate stability. That stability is because of the moon. You want to know something even scarier? Mars. Look at Mars. It has two tiny moons, Phobos and Deimos. They're basically captured asteroids, and Mars wobbles. Its axial tilt has varied from 0 to 60 degrees over millions of years. That wobble is likely why Mars lost its atmosphere. Without a stable tilt, the climate changed so dramatically that the planet couldn't hold on to its air. We're not Mars, but we could become Mars. Back to the thought experiment. The moon disappears tonight. The next few weeks, you'd notice weird weather. The tides are off. Birds are confused. Nighttime is darker. But you'd survive. The next few years, agriculture gets harder. The seasons start feeling wrong. The next few decades, entire ecosystems collapse. The next few centuries, ice sheets behave unpredictably. The next few millennia, we're in deep trouble. But here's the paradox. The moon is also the reason we exist at all. Without the moon, life might never have gotten started, because the moon created tidal pools. Those pools were the first laboratories of life. Water in, water out, concentrating chemicals, creating the perfect conditions for the first molecules of life. Dr. Peter Ward, a paleontologist at the University of Washington, has argued that the moon is a key